Hi, my name is Kate and I'm a developer advocate for Kotlin. In this talk, we are not going to spend much time discussing why you should try to make your applications cross-platform. Don't repeat yourself is kind of a mantra, the main principle on which a lot of architecture patterns are based, and it's because of many heated discussions in pull request comments. Reusing code is good, and we've all known that for a long time. This is Alex and Anne. They in love with mobile development, but neither of them likes doing the same job twice. So today we'll help Anne and Alex to take a journey into a wonderful world of cross-platform mobile development, and we'll see how KMM will help them along the way. We'll look at all the different stages of mobile application development and learn how to use KMM features to optimize them. How do we usually proceed after we decide to stop duplicating the same code for different platforms? Of course, we start by comparing the existing solutions out there and looking for one that will best fit our needs. Because the choice we make could greatly affect the architecture of our existing applications and any we create in the future. To understand the variety of options available, let's first take a look at the architecture of a standard mobile app. Basically, it consists of several layers: the UI layer, presentation layer, business layer, and data access layer. If we imagine a scale where the bottom point is core and the top point is UI, we can see that the most popular cross-platform approaches are UI-centric. What does it mean? Well, it doesn't mean that you can't write business logic code. Of course you can. It means that the whole ecosystem is focused mainly on developing UI components. But when you decide to write something more complicated than just sending HTTP requests, you will be almost alone in this wild, vast cross-platform world because of a lack of libraries and practices. However, these technologies allow you to create similar interfaces for your apps very quickly. So this approach is absolutely justified when you have simple apps, thin clients, or if you just want to make an MVP to test your product assumptions. But when your product starts to grow, the UI quality and responsiveness requirements get stricter, and the business logic becomes too complicated for your UI-centric approach. This is where the business logic-based approaches came in. We already have well-known players here, such as strategies to have shared C++ or JavaScript code. As always, they come with different advantages and disadvantages. One of the most harmful disadvantages is the need to add one more additional language to the existing code base, together with its own tooling, ecosystem, and rules. Well, this doesn't seem like the easiest way to avoid duplicating some parts of your code. Let's go back to Anne and Alex. Anne already has an existing project with complex logic, while Alex has just started to plan his new mobile app. But he has big ambitions for it, and he doesn't want to find himself rewriting his entire application one day. So they both want to share only a specific part of their code, and they don't have time to learn a new language and deep dive into an unfamiliar ecosystem. Well, folks, good news for you. You can achieve this with Kotlin Multi-Platform Mobile today. With Kotlin Multi-Platform Mobile, Ant and Alex can immediately start sharing business logic between iOS and Android applications in any project without any limitations on the UI development process and in their favorite language. Sounds good, so let's have a look. Some of you, of course, may have heard about Kotlin Multi-Platform, or KMP. Some of you may have heard about Kotlin Native, and some of you may have just started to learn Kotlin. Hey, welcome! To make sure we're all on the same page, let's make things clear and figure out what Kotlin Multi-Platform Mobile is. Kotlin Multi-Platform Mobile, or KMM, is an SDK for cross-platform mobile development. It uses the multi-platform capabilities of Kotlin and includes various tools and features designed to make the end-to-end experience of building mobile cross-platform applications efficient and enjoyable. KMM allows you to use a single codebase for the business logic of iOS and Android apps. You only need to write platform-specific code where it's necessary, for example, to implement a native UI or when working with platform-specific APIs. Whenever you want to use iOS or Android features, you can use the expect actual pattern to write platform-specific code with shared logic in the KMM module. KMM is seamlessly integrated with your mobile project. Shared code written in Kotlin is compiled to JVM bytecode with Kotlin JVM and to native binaries with Kotlin Native. So you can use your KMM business logic modules just like any other regular mobile library. And KMM doesn't impose any restrictions on how you develop your app's UI. So KMM equals Kotlin multi-platform plus the mobile-specific stuff around it. What is the mobile-specific stuff? The best example is the new KMM plugin for Android Studio, which allows you to write, test, run, and debug shared code in the same IDE. But let's start from the beginning. Let's go through the development process of a typical mobile application and see how we can use KMM to make it cross-platform. But before I start speaking about app architecture, let's first figure out what kind of projects are suitable for integrating KMM. Alex is lucky. He has a new project. It's always easier to speak about app architecture when we are going to create a new application. You have a drawing board in front of you, and you can use whatever architecture you want and almost any kind of technologies, as long as your company doesn't mind. But Anne already has a project, and she doesn't want to wait for a new one to start reusing code. So what about existing projects? Do we need to go back to the drawing board to start sharing code between platforms? Good news? No, you don't. KMM is seamlessly integrated with any mobile project. Shared code written in Kotlin is compiled to JVM bytecode for Android and to native binaries for iOS. So you can use your KMM business logic modules just like any other regular mobile library. So technical details of KMM integration are the same in both new and existing projects. Just add a new dependency. The only difference is in the process. For a new project, you can start developing new features in the shared code, then write native UI and connect it with your shared business logic. There are different strategies for integrating with an existing project. You can take Kotlin code that has already been written for Android and refactor it by using only pure Kotlin libraries and make it compatible with iOS. Or you can take a new feature from a backlog, and then the process will be the same as for a new project. So let's help Alex with his case. Alex loves space, so he wants to create a mobile application that will get information about SpaceX launches, store it in a local database, and display it in a list. Well, yes, it's quite a simple application, but as always, it's a beginning of big story. And as the integration of KMM is almost the same for both new and existing projects, and anyone else who wants to use KMM with an existing code base can easily use the same approaches. Okay, so we need to develop a typical mobile application that retrieves data from the API, displays it in a list, and caches it in a local database. On the first architecture design stage, we need to decide what part will be shared and what part will remain native. Let's go back to our architecture diagram. KMM is designed to allow you to share the business and core layers of your app. When we're creating a new mobile app, we don't want to spend a lot of time thinking about organizing the data layer. It's such a common task, so there should definitely be some building blocks to do it quickly. KMM provides exactly these building blocks. The ability to use platform-specific APIs along with expect actual pattern allows you to create them without reinventing the wheel. The Ktor HTTP client is a good example of such a block. Like all multi-platform libraries, it provides several artifacts, one with common logic for all platforms and drivers for different platforms, which allows you to use the platform-native capabilities to perform HTTP requests. The other building block we need is Kotlin-X serialization, which we will use to deserialize JSON responses into objects of entity classes. And the last one is SQLDelite. This will generate Kotlin code from SQL queries to create a type-safe database API, which we will use to communicate with databases on iOS and Android devices. As a Ktor library, besides the core artifact, SQLDelite also provides platform-specific database drivers, one for Android and one for iOS. For the domain layer, let's add a couple of entities. In Alex case, there should be entities for rockets and for launches. And let's also add wrappers for Ktor and SQLite libraries that will allow us to get the data as business entities and hide some code details. The entry point to the KMM shared model will be the SpaceX SDK class, a facade over our networking and caching service. Now we have a mobile SDK, which could be used in our application. It also can be easily distributed as a separate mobile library to allow other developers to create clients for our web service. This is a very simple KMM module architecture. It's quite enough for Alex purposes, but of course you can write more layers of abstractions to make your code even cleaner. Now, we are done with architecture, so let's figure out how we should configure our project. There are three main parts of any Kotlin multi-platform project: targets, source sets, and compilation. A target is a part of a build that is responsible for building, testing, and packaging the application for a specific platform. Source sets are collections of Kotlin code files along with their resources, dependencies, and language settings. A source set can be used in Kotlin compilations for one or more target platforms. Each target can have one or more compilations, for example, for production and test purposes. In our cross-platform mobile project, we need to declare two targets, Android and iOS. The common dependencies that are used in all targets need to be declared in the common source set. In our case, they are Ktor, Kotlin X serialization, Ktor serialization feature, and the SQLite runtime. And since Kotlin 1.4, stdlib is added by default to any Kotlin Gradle project, and there is no need to declare it explicitly. Thanks to the new multi-platform libraries publishing format, since Kotlin 1.4, you should specify a dependency on the multi-platform library only once in the shared source set, instead of specifying dependencies on different library variants in all source sets where it is used. So we can declare a dependency on Kotlin X libraries or on the Ktor feature, as in this example, just once in the common source set. However, we still need to explicitly specify dependencies on Ktor engines and SQLite drivers, because there are many of them, and it's impossible to determine automatically which of them to use. This tiny iOS declaration hides some tricky KMM model configuration details for iOS target. The thing is that the iOS simulator and iOS device currently have different processor architectures. So to be able to run and test our app on both of them, we need to compile our shared code for two targets, not for one. Starting from 1.4, Kotlin multi-platform supports a hierarchical project structure that allows you to have intermediate source sets and use platform-specific APIs in them. You don't really need to think about it while you're working on the shared code of your mobile apps. Everything just works out of the box. But if you want to know more details about how all this works under the hood and what engineering challenges we overcame to make everything work as it's supposed to, watch Dima Samenov's talk. It's a very interesting journey, I promise. Before we start writing code, let's discuss our app architecture a little bit more. Well, I know for mobile developers, discussing different architecture is considered to be a hobby. Jokes aside, we've discussed core and business layers, but what about presentation? Do we need to share it or not? We definitely can do this, and there are already many community libraries that allow you to do this and have plenty examples of their usage. But you need to think carefully. Do your apps look similar enough to have one presenter of your model or controller for both of them? Could this change? I'll let you make the decision for yourself about your apps, and we will go with only shared business logic. After all, it's never too late to do some refactoring and move more layers to the shared model if you are sure that it's worth it. Our application architecture is now designed, and we know how to configure our project. Let's finally write some code and discover some KMM features. Of course, KMM is seamlessly integrated with Android. Use Kotlin for every part of your project and work in the same IDE both for shared code and for platform code. But we are writing shared code for both platforms, and KMM also provides tight integration with the iOS development process. Thanks to the Kotlin native bidirectional interoperability with Objective-C Swift, you can call Kotlin code from Objective-C Swift and use iOS libraries from Kotlin. You can integrate KMM models in a natural way for iOS developers using the CocoaPods Dependency Manager. And you don't even need to switch IDEs while working on the shared code. With a new KMM Android Studio plugin, you can write, run, test, and debug shared code all in Android Studio. Let's take a closer look at these features. Alex created a single function in the SDK class, which returns the list of launches from the database. So we can easily use our KMM module API in Swift. Kotlin's list is mapped to Swift array, so calling this function looks very natural. But before getting the cached data, we need to load it somehow. So we need to make an HTTP request. GetAllLaunches is a suspending function, so our public getLaunches function need to be marked as suspending too. There is no such concept in Objective-C Swift, but you don't need to worry about it. Suspending functions are available in it as functions with callbacks. When you have such functions in the generated framework's header, you can call them from your Swift or Objective-C code and even override them. Our HTTP client can throw an exception during the GetAllLaunches call. There is fundamental difference in error handling between Kotlin and Swift. All Kotlin exceptions are unchecked, while Swift has only checked errors. Thus, to make Swift code aware of expected exceptions, Kotlin functions should be marked with a throws annotation specifying a list of potential exceptions classes as parameters of throws annotation. Now we can handle all exceptions in our completion handler in Swift code. This was just a small example of Swift Objective-C interop possibilities. It supports all fundamental concepts and doesn't require additional setup, allowing you to integrate with KMM models in iOS applications without a headache. Kotlin Native also provides integration with CocoaPods Dependency Manager. You can use KMM models as a CocoaPods dependency, or you can add dependencies on pod libraries stored locally or in the CocoaPods repository. You can manage pod dependencies directly in Android Studio, enjoying full coding support. On the subject of Android Studio, with a new plugin, you can create a new KMM project or module with just a few clicks, and you get integration with your iOS device and simulator directly in Android Studio. With a new Kotlin multi-platform mobile project wizard, you can create a ready-to-run mobile application project with a shared codebase in just a few clicks. The generated project will contain examples of how to connect to platform-specific APIs and basic test coverage. You can use this wizard to explore basic features of KMM or as a scaffolding tool for your new KMM production application. I'm sure this wizard will help Alex start developing KMM applications much faster. You no longer need to switch IDEs and have Xcode running to check that your code works correctly on both mobile platforms. You can run and debug the iOS application on the simulator or device with the predefined run configuration. You can run and debug common and iOS-specific tests on the iOS simulator by simply clicking the Gutter icon on a test class or test method. For both the application and tests, you can set breakpoints and debug your code on iOS. After writing our code, we want to test and deploy it, obviously. You'll be glad to hear that there are no big differences in this process, as your shared code is connected like any other regular dependency. Only difference, if you want to optimize your manual QA work now, is that because the business logic code is reused, you don't need to test some features on both platforms and you only need to do it once. Congratulations! We've designed the architecture of our app, created a project with a KMM plugins wizard, written some code in Kotlin, and integrated it into both our iOS and Android apps. You can find the complete project with a step-by-step tutorial at our hands-on portal and use this as a guide to creation your KMM application. Alex and Anne looks really happy because now they definitely know how to stop duplicating code for mobile platforms. And we've learned that it's definitely time for Kotlin multi-platform mobile. Why is today a good day to start? KMM is now in alpha. This means that the Kotlin team is fully committed to improving this technology and helping it evolve. It's also a signal that the product will develop quickly from here now. Going alpha means that everything is ready for you to start using KMM to share business logic code between mobile platforms. You can create a new project or easily integrate a KMM module into the existing one. In both scenarios, work can be done with minimal cost and you can always go back to fully native development. And the community is growing really fast, and you can influence the development of the whole ecosystem by participating in it. So what's the best way to start? The new KMM Developer Portal is your trusted resource when you are working with KMM. You will find content for all levels of expertise, from tutorials to get you started to more advanced development topics. It contains useful information about common tasks like organizing networking and data storage layers and even organizing the development process around KMM. Looking for new ideas about benefits of using KMM in your application? Learn from a first-hand experience of a variety of teams, for example, VMware, Quizlet, and Yandex, who are already using KMM in their products in the case study section. And try the new KMM plugin. With the new wizards and iOS integration, you can create a new KMM project in a few clicks and start exploring all the KMM features. Thank you and have a nice Kotlin!